Welcome to Lecture 2 on Kinematics of Particles. Lecture 2, Kinematics of Particles. So first of all, in this chapter, we are idealizing physical objects as particles. So what we are saying is that their shape and their volume and their area, their size is not going to be important, and we are going to treat the physical objects as a singular particles where all of their mass would be concentrated. So which means that the only inertia term we are concerned with is the mass, not the moment of inertia about various axes. So that's first assumption we are making. The second is that in this chapter, we are not going to be talking about forces or the moments that give rise to the motion of physical objects. So we are only concerned about the kinematics, which is defined as geometry of motion. So kinematics is called geometry of motion primarily because it looks like you are studying the various properties associated with the motion of a particle along a path and the derivative of its displacement, such as velocity and acceleration. So if you have a particle traveling along a path, if you're talking about its displacement with respect to some fixed reference frame, let's say this is the position vector r given to you for this particle at time t, then after a certain time, it may be in a new position, let's say p prime, at time t prime, and then it will have a different position, let's say r prime. So going from position p to p prime, there is a change in position vector, and that gives rise to the velocity, and that in turn could give rise to acceleration. So in this chapter, we are only concerned with quantities such as position, the change in position, which we'll define as displacement, the velocity at a certain instant, as well as acceleration. So these are the four primary quantities of interest that we are going to be studying in this chapter. And we will do this in different coordinate system because there are certain kinds of problem where one kind of coordinate system may be useful. There may be another kind of problem where something else may be useful. So we will talk about what we call Cartesian coordinate systems, which I'm pretty sure you have seen in your previous classes. And we will talk about curvilinear coordinate system, where actually the coordinate system changes its orientation as the particle moves along a certain path. Now, this chapter actually has quite a bit of math in it, especially vector algebra and differential and integral calculus. In fact, the good news is that this is the only chapter where probably you have a lot of math. And after this chapter, the math actually kind of goes down. So, don't be alarmed by the kind of math that we'll be seeing in this particular chapter. But it does require that how to differentiate vector functions as well as integrate some of them. Okay. All right. So let's start with something very, very simple.